Okay, for this example, we're going to sketch the graph of cosecant x and then answer a question about a limit of cosecant x. So to begin with, let's remind ourselves that cosecant x is the reciprocal of sine x. And how can we remember that? Why not cosine x? Well, it's because it is sine x, but reciprocal sine x. One thing that someone told me a long time ago is this memory device, the cos don't go. So what I guess that means is that cosecant x does not go with cosine x. The cos don't go. All right. When sine x is equal to 0, we're going to have a 1 over 0 form. So if sine x equals 0, we'll get 1 over 0, which will lead to a vertical asymptote. Again, 1 over 0 is undefined, but that form can tell us a lot. The 1 over 0 tells us about there'll be an asymptote. Now, when I draw this graph, I'm not going to do it to scale. The x and y axis to scale. I'm going to start off by sketching the graph of sine x, which is a wave. I could probably try better, a little more harder to make this to scale. See, this one cycle has length 2 pi. So the period of sine x is 2 pi. Pi is around 3, so 2 times 3 is 6, and that's not what I showed here. But okay, let's stick with that anyway. And so here we have 1 and negative 1. So this is y equals sine x. All right. Now, as I said, we are going to see vertical asymptotes when sine x is equal to 0. Vertical asymptotes of cosecant x. Now, when is sine x equals 0 on this graph? This is y equals sine x. When is sine x equal to 0? Well, we can see that's when those are at the x-intercepts. So the x-intercepts are where sine x is equal to 0. The x-intercepts are when the y coordinates equal to 0. And those will correspond to vertical asymptotes for 1 over sine x, which is cosecant x. And I'm going to draw those vertical asymptotes. And so far, all of these things are actually just sort of a guide for sketching the graph of cosecant x. None of these things actually are the graph of cosecant x. These are just guides. All right, now I'm going to try to explain to you how I'm arriving at the graph of cosecant x. But essentially, if we plot enough points and connect them together using a graphing program or something, that's how we can get the graph. But let's try to memorize this and understand it a bit. Or I think we're understanding it. Let's see if we do. Okay. So, all right. Cosecant is the reciprocal of sine x. And so where I'm putting this red dot, I see that's on the graph of sine x, and I see the y coordinate is 1. Now, if the y coordinate of sine x is 1, I'll take the reciprocal, and I'll get the y coordinate of cosecant x. The reciprocal 1 is 1. Let's go down, say, where the y coordinate of sine x is a half. I'll put those 2 dots there. So sine x is a half. Cosecant is the reciprocal, and so the reciprocal of 1/2 is 2. So here I am up here. I don't know, is there something? Oh, I actually should label this a little more and point out that this is pi over 2. And let's see, if you are interested, you might remember, hopefully, that sine of pi over 6 is a half. So this would correspond to pi over 6. So maybe it should be moved over a little bit to the left. But roughly speaking, okay, it's pretty close to about right. Let's just say, okay, down here, maybe sine x is where I'm putting those dots is looks like 1/5, and the reciprocal of that, when I find the point on the cosecant graph, is 5. Roughly speaking, but the result is that I have something that looks like a loop for the cosecant graph. I sort of want to do it even better, but that's how it looks. And is that you look at the y coordinates of sine and you find the reciprocal. But to get this really done well, we need to use a graphing program that plots, thousands of points. But that's the idea. And so essentially, without spending a bunch of time, we sketch the graph of sine x. We put vertical lines through the x-intercepts of sine x, and then we draw these loops. And this part that's in red now is the graph of cosecant x. And let's see, what else can I say about this? The process for finding the graph of secant x is very similar. So I'm not going to do an example of secant x. But let me also, I think it's definitely worthwhile to fill in a few points, especially I think we should, I got that one wrong though, but I think we should pretty much always expect that we should label the vertical asymptotes. Okay, so what do we have here? This part in red is the cosecant x graph. The part in blue is the sine x graph, or we're trying to do the cosecant graph. Now, let's look at this graph and through the graph answer the question, what is the limit of cosecant x as x approaches pi from the right? So that, that little plus there means from the right of what? From the right of pi. So I look, for x equals pi, and I see pi, and then I hop on top of this graph of cosecant, and I start getting closer and closer to x equals pi. And what do we have? We do not have a limit. It's not a limit. This is an infinite limit. All right. So if someone said, what's the limit? The limit's actually undefined. But what we have is an infinite limit. And the infinite limit, because the graph is going down, 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 is negative infinity. All right. That's what we get, negative infinity there. I'm hoping that someone will speak up if I did it wrong, because this is a video and I don't want to throw away the whole video. I can just correct it now. Once I close up the video, then we're done. But is everybody all right with that? Any like, hey, you got something mixed up? What do you say?
Could it also be positive infinity?
Oh, what?
Could it be positive infinity as well?
No, I mean, that would be the answer to a different question, but I don't believe so. I don't. What? It's as we go to pi from the right, we're going down. So down is what negative infinity means is the meaning of it is that the y value is getting to be a large negative number, and we can make it by getting x closer to pi from the right side of pi. We can make it even bigger. Let's do another one. Since we're already here, we already spent time writing that up. Let's find the limit of as x approaches negative 2 pi from, I don't know, from the right. I'll do that. Well, let's do, no, actually, let me do one a little different so we don't do something a little bit mixing up. Okay, negative pi from the left of cosecant x. Okay, let's see if you can figure that one out. Okay, so what does this thing right here, that minus mean? That means that we're coming from the left.
That's just the positive infinity, right, Professor?
I think so, but let me double check what you said. I think you got it right. Here's negative. Okay, so where's the negative infinity? See where we're looking? The other one was pi. I'm sorry. Where's negative pi? Negative pi is right there, and I'm to the left would mean I hop on this red graph on the left of negative pi, and I go up. So that's positive infinity. Okay, so now I see maybe I highlighted, maybe that would have something we could see for part B. I have pi, which I've highlighted, you know, where I labeled that vertical asymptote. And so I hop on to the right of that, and it just takes me down. By the way, also, maybe should I require it? I mean, I label pi, but see that the equation of the vertical asymptote is x equals pi, etc. Anyway, so okay, those are vertical lines. Okay, so let's just back up a little bit, and cosecant x is the reciprocal of sine x. The cos don't go. Cosecant does not go with cosine. Goes with sine. All right, and all right, so let's close up.